That was a weekend.
Great. How was yours?
All right.
How was your weekend?
Oh, it was good.
What'd you do?
Went to Iowa.
What did you do in Iowa?
Wasn't for a race. No. Back for those things. It was nice because of weather.
If I don't give you your, I don't refund it.
Nope. Well, I was going. The money was going to the children's hospital, so I don't really have a problem with
so
it.
it's
Yeah. I don't really have a problem with that.
These state children taking up all our money to get our money back.
So I test tomorrow, yes.
What time is it?
You can come in whenever you'd like. It's only home at time.
Okay, but I need to, like, how late are you gonna be here?
I can start you and not go.
Oh, right, I can just slide it.
Yeah, you can start it.
But like, Dr. Joe, I would.
I can't be there.
What is that about? Does Wednesday work better?
No, because I have class at 6.
No, I meant. You want to make time during the day?
Do we have probability tomorrow? Yeah, we do.
Yeah, we won't have this class on Wednesday.
You're probably ours. You might be the only one here.
What? Oh. Wait, no, I didn't. So we don't
Hi.
have probability.
Dr. Joe, is Dr. Stuckey still out?
Yes.
Dr. Joe, I have no
Oh, it needs to be 6, and I'll do 6.
I don't get out of practice until 7:30. Dr. Joe, you.
Well, Haley's going to be here, so apparently she can start on these.
So if we're doing a late nighter, I might just do a late night test too. That's the plan.
How long is it gonna take us, you think?
What's the problem?
10 problems.
Remember what happened with the
So like not
probabilities?
that long.
Remember what happened with the probabilities?
Probability is way harder than this class. 100%. Not even close.
Theoretically, you should be able to do the test in an hour. But in the actual exam, you should be able to do 10 problems in an hour.
I did it. That's just stressing me
For
out.
50 minutes.
The test is stressing me out. When I'm supposed to take it is stressing me out.
Yeah, more.
Are you post review solutions online? Like step-by-step solutions? Or,
I think I can probably get that done this afternoon.
okay, thanks. I was looking for it this weekend to check.
Oh, yeah, I just hadn't. I've got the solutions actually done. I just took the reviews from last time I taught the class, so I just need to. I gotta recompile it and put it back in there. But I gotcha. That's,
Just thought I'd ask.
I'd forgotten.
For review solutions, because
So yesterday I was reading a whole bunch of papers for freshman
it's all the freshman seminar.
I know a couple friends.
A philosophy seminar? Math seminar?
Yeah, we're talking about misuse of representation of data.
Are you making it super hard?
No, it's a freshman seminar.
So,
It's not an honor seminar. Freshman seminar is not supposed to be really hard, in my opinion. So it's not. I just think I'm right.
what if you taught an honor seminar? Would you make it really hard?
It would be harder than a freshman seminar. But it's not a little class, so that would make it really hard.
If you did like a 300 level honor seminar,
Well, that would be really hard.
would it be like abstract algebra hard, or would it be more like Calc 1 hard?
Are you doing an honor seminar next semester?
No, I'm not. Dr. Olson is.
I don't know.
Dr. Coop?
That's just
What's she doing?
the most opposite of
Her data one.
Like the,
Is that the 200 level?
Yeah.
So,
Yeah. Sorry.
Dr. Olson doing it?
anybody know if human nature is 200 or 300?
Don't do it yourself.
I'm in it right now.
Oh, I'm sorry.
I thought it was 200. So I got 200, but somebody told me it was 300. So I was like,
I think it's
It's whatever it is.
350s are the only one being offered. There's no
road testing. They took away my honor seminar I was gonna take.
Yeah, they took away my.
Najiba, I've been taking Najiba for the boss.
Yeah.
International trade, it's supposed to be a blow-off class, and then
Took away.
they replaced it with a theater class.
No.
I had nothing to do with it.
I know you
I'm
didn't.
so
That's what happens when you let business teachers or something.
Anyway, you can do the test whenever, tomorrow or even Wednesday if you want to do it Wednesday. What's that? Yeah. We don't have class Wednesday. We don't have this. We do not have this class on Wednesday.
Can I finish part?
Yes, you can play tomorrow. What's wrong?
Cindy just processed what you said.
I'll probably be more tired
We also do not have class a week from Friday.
You have the conference of Michigan. Wisconsin.
Wait, what? I just was what was next Friday.
Next Friday we will not have class. Or probability.
But we'll have to hear not hear probably. Okay.
Don't worry, Dr. Joe, we still have it.
Okay, go right ahead. You go right ahead. No, that's.
Oh, that would have been so cool.
Well, one of the classes, we won't have probability.
On Wednesday?
Yeah.
So that means that I can go home on Wednesday. I can go home on Wednesday.
You still work the, don't you, Grace?
Yeah, you work Thursday night.
You don't work there fall break.
I was asking about Wednesday.
Is she gonna have it open Wednesday night for fall break?
No, she was that.
I was gonna
I
like, usually she
only work
closes on
Mondays,
Tuesday, I thought.
I mean, I would take the easy hours. Nobody's gonna show up, so
I mean, that's fair.
That would be easy hours.
I'll sit there for 6 hours. And
Sit there for 6 hours and nobody's there.
6 to 12. We'll open it for an extra 2 hours that day.
You sure you want to keep going with the penalty there, Marshall?
You know.
I don't think we did the 2 to 4 and the 6 to 10. That would be 6 hours.
Yeah, he said 6 hours from 6 to 2.
Oh, I missed that part.
Yeah. My arithmetic's not my strong suit right now. What? Yeah, I was impressed by how well that went. But I heard over here.
All right, so just to review a bit. So remember we use our little a of t for the accumulation factor. And then of course we just multiply by the present value to get our accumulation function. For simple interest, remember that the interest is only computed on the original principal, so we get this accumulation factor. Simple discount. How does simple discount differ from simple interest? Or in general, how does discount rate differ from interest rate?
1 over I.
No, 1 over 1 plus I is 1 minus D, right? So, but a simple discount, it's always based on the accumulated value versus the present value. So the reason why this is divided by the 1 minus d times t is because we're discounting off the accumulated value. So the accumulation function works off of present value, so we have to have the division in there. It'd be like solving for the accumulated value. This was back in chapter 2 stuff, right? The first video you watched a while ago. And then for compound interest, we've got the 1 plus I to the t. Of course, we have to make sure that that's an effective rate per period. For that formula. And then t counts number of periods, right? Same for compound discount. So far, so good. We also did nominal rates, right? So these would be your formulas for effective rate per period, and then T is your number of periods. If you're doing a nominal rate, compounded M times per year, your accumulation function looks like the following. Basically, it's the exact same formula as above, well, 2 lines above. Because remember, when you have the nominal interest rate quoted, you have to divide that interest rate by the number of periods. And if you're at the M times T, they're representing number of periods. Right? And then the one for discount rate looks the same. Notice the formulas look very similar to each other. Just, basically minuses where the pluses were. What else did we have? We had force of interest. We'll use delta for the force of interest. So that's just e to the delta t is your accumulation factor. If you've got a varying force of interest, you have to do an integral up in the exponent. Just as a reminder, another way to define your force of interest is using a differential idea, derivative idea. That popped up in one of the homework problems, I believe. There might be a formula or two. Which one? This one? Yep. Hey, what else we had? I think this was all the stuff that we had for what I call lump sum problems. You put money into an account and leave it, and then get something back at the end. Then we started doing annuities. So we had the notion of present value and future value of annuities. Remember, annuity immediate is at the end, the deposits or payments are being made at the end of each period. Versus the annuity due, they're made at the beginning of each period. The only real difference between the formulas is that you've got a D in the denominator rather than an I.
What's the S stand?
It's future value, accumulated value. Oops, forgot my umlaut over the S. Am I missing any formulas from those? I know we have some other conversion formulas from one to another, but am I missing anything?
Oh, the perpetuate.
Oh, perpetuity, thank you. I was missing something. And I know, pardon me, a lot of the notation that you'll see has the interest rate on the ends here. In most problems, the interest rate's going to be just one thing. It's going to be some I on the other side of the bracket. It's possible you might have two different annuities going on at different rates, so you keep track of. Because, of course, the V also is based off what that interest rate is, right? The V is 1 over 1 plus I, so it's also based off the same I. All right, we have a few conversions.
Well, you should put the
What's? Yeah, I'm going to. Yep. For what V is, I'm going to write it down for these. Yep. Yeah.
So there's the one equation where you can do the 1 minus d times 1 plus I equals 1.
Yep.
And then there's the other one that's more complicated. Like, what's the difference between using that and then the 1 plus I times t equals 1 over 1 minus t times?
One of them is, pardon me, goodness. That first one that you said just is putting a T over in there. So the other one's true in general. Usually we think about it in the second way if we've got different number of times compounded per year. So that's why we think of it the other way, a little bit easier. So you mentioned this one. Oops. That product has to be 1. If you've got, and this is important actually, if you've got interest rates that need to be converted from one period to another, I personally like to think of it just as that equation personally. Say you're given a nominal rate for a certain number of periods that need to change into an annual effective rate. So all we're doing is just basically equating the time of 1 here. If we can think about doing this for other ones, we can do the same thing with the compound or the discounting ones. So if you've got a compound discount rate or a nominal discount rate that's been compounded k times per year, you can equate it to a nominal interest rate, compounded m times per year, or you can get an annual effective rate or any of those things by I like thinking about just getting equated to 1 year and then setting up the formula that way rather than trying to make up a formula.
So both equal 1 plus I, or should that be 1 plus D?
Nope, they're all both equal to 1 plus I. Because if you want to convert from a discount to an effective, you can use this one. If you want to go from a discount to a nominal, you can equate the two. If you want to go, if you've got two different nominal rates and want to go from a rate from, say, quarterly to a semi-annual rate, you can also do it that way too. There's our formula, a couple of different ways to convert your V. V is 1 minus D. It's also 1 over 1 plus I. You also have that D is equal to I times V. Just a couple of different ways to play around with interest rates. So honestly, as far as, and this is just true in general, I personally think of exam.fm, it's more of a vocabulary test than it is a math test. Because you have to read the problem to figure out what formula to use. Right? Once you figure out what formula to use, the formulas are pretty basic formulas. Right? We will do a little bit with geometric series after this test. But again, that's just one formula. Right? We actually talked about that formula for coming up with the formulas for the annuities, and we're going to get some other types of formulas, but basically it's read the problem and get it set up so that you can figure out what formula to use. So let's look at a couple off the review sheet, since we clearly have time. Do I have a review sheet with me? Didn't I hand it out last time?
These test questions will be pretty straightforward.
I hope so. Yeah. That's why I said I hope they're straightforward. Anybody not get the handouts last time? Here's one of them. This is one of them. Hey, look at that! I can get one here in a second.
Are the answers on?
Not yet.
Example 1 review.
That was what Marshall asked me about a minute ago. Actually, it was longer than a minute, but that's what Marshall asked me about.
Wait, there should be 2?
What?
2 sheets.
Just the one for the review. The other one was the basic review problem.
Yeah.
Let's just start working through some problems and see what we get here. Got a a deposit of X is made to a fund that pays an effective interest rate of 6% for 10 years. And at the same time, X over 2 is deposited into another fund that pays an annual effective rate of discount of D for 10 years. The amounts of interest earned over the 10 years are the same. Calculate D. So the first fund, as it pays an annual effective rate of 6% for 10 years. So what will be the amount after 10 years? Cool. Yep. 6% interest rate that I'm going to add to 1, so I get 1.06 for 10 years. So the amount after 10 years of the first fund is going to be just that. How about the amount in 10 years for the second fund? Okay. Haley, are you good? Oh, purple.
She is.
Color would be the
Oh.
It was a compliment.
It sounds like a backhand.
It was
sound, right? All right. Do I want to equate these two things? No. Why not?
That's what.
That's not the interest, right? That's the amount, isn't it? So if we want we want to equate the interest. How do we calculate, or how do we calculate the? I guess it was what I wanted to ask. How do we calculate the interest here? Okay. So for the first one, we'll subtract, and the second one we'll subtract x over 2. So that will give you your interest for both in 10 years. Does it matter what x is? No, just divide out, right? So at this point, we should be able to solve pretty easily, correct? Divide out your x to get rid of all the x's. Add over a half. Reciprocate and take the 10th root, and then rearrange your equation. Do we need to do the algebra, or are you okay with the algebra? Please tell me you're okay with the algebra. What's that? I don't know. Okay. Is it like 9.090909? Okay. Sure. I don't know. I was just making it up. I have no idea. That's one of the favorite answers it likes to do, or at least somewhere in the problem is 0.909090. I don't know why. Okay with that one?
So why do we rate it that?
Because it says the amount of interest earned are equal. Amounts of interest earned are equal. So this is the interest for the first fund. That's the interest for the second fund. Because we're taking our accumulating as our present values to get the interest. All right, let's look at the second one. Since we had so much fun with the first one. Haley did. She was handing out compliments all over the place. All right, second one. So again, like I've mentioned a few times, one of the things that's important in these problems is being able to read and understand what it is you're trying to do. Now I know this one says calculate x or find x or what have you. The important part here is it's telling you that the accumulated value in 10.5 years is a certain value, right? Can we set up a formula that involves that information? What would the formula look like? Okay. Yeah. Over. Okay.
Oh, no, sorry, I was still on this one.
Yep.
To the 14th again.
Okay. Everybody see where that's coming from? Interest rate of I, the nominal interest rate of I, compounded semi-annually for 7 years, so there's 14 semi-annual periods. Remember, this exponent, when you're doing compound interest, always has to be number of compounding periods. Then the interest rate changed to 2i, but then we also changed the compounding periods to quarterly for another 3.5 years, which is 14 quarters. And we know that accumulated value has to be 1980. Notice that at this point they've made the algebra, well, I'll say easy, but they've made it nice, right? Because 2i over 4 is the same thing as I over 2, so we have the same bases, so we can just add our exponents together, right? And get to 1,000 times, now I'll even divide the 1,000 over. 1 plus I over 2 to the 28th is 1.98. Would you agree with that? Now, if you're clever, you don't have to figure out what I is, by the way. You can actually use this value for what they ask you for. I don't like, it does not hurt for you to figure out what I is. But again, if you're going to take exam FM, it is a 35-question test in 3 hours. If you can find ways to save time, you're going to do it. Okay? One of the ways to save time is that if I don't need to calculate something, I'm not going to calculate it. Okay? I just need to use this value. What is it they're asking you for? It's asking you for the accumulated amount at the end of 5 years, right? We agree? So the accumulated amount in 5 years is 1,000 times 1 plus I over 2 to the 10th, right? Would you agree? Well, I know that 1 plus I over 2 to the 28th is 1.98, so I can do 1,000 times 1.98 to the 10 over 28. That'll change it to what I want, right? 1.98 is 1 plus I over 2 to the 28th. So if I take that to the 10/28ths power, I get it to the 10th, right? If I take both sides of this to the 10/28ths power, I get to the 10th, which I want here. Again, you do not have to do this on this test. I'm just trying to give you little tips here and there that pop up as you go through studying this. If you're not going to take this exam, then you can ignore everything I've said the last 2 minutes. Or if you want to worry about it later, you can ignore everything that I've said for the last 2.5 minutes.
So if the answer is one more, then the answer is 7.
The answer is one more than one of the answers. Yeah, that happens. You always pick the closest. What is it, 1276? Yeah. Fine. I've seen these problems a few times. I tend to remember what the answers are. You know, sometimes your answer will be not exactly what's on the page or on the computer screen. You're taking the exam. I mean. But it should be closer, much closer to one of the answers than the other. Someone okay? Let's just keep going down the line. It's kind of fun, isn't it? Or you want me to skip down the line? Okay. Sure, why not? Okay. So it says Project P requires an investment of $4,000 at time 0, pays $2,000 at time 1 and $2,000 at time 2. And then you've got Project Q requiring an investment of X at time 2, and the investment pays $2,000 at time 0 and $4,000 at time 1. Yeah.
Is this one of those ones that you use the calculator sheet on the calculator for?
If we were trying to figure out what the interest rate was, yes. But then we don't need to use it in this case because we're given the interest rate. Actually, if it asked us, try that again. If it asked us for the net present value, we could use the cash flow worksheet. But we don't actually need it in this case. Okay. All right, so it's asking you for net present value. What that means is that if I take the present values, thinking about the way the cash is flowing, that's the net present value. So if you got money going out and money coming in, the signed sum of that is your net present value. Okay? So for project P, it says it requires an investment of $4,000. Is that money going out or coming in? If you're thinking about you, is that money going out or coming in? They're going out, right? So that would be negative $4,000. Pays $2,000 at time 1. Is that money going out or coming in? Coming in, right? So I would add 2,000, but those aren't at the same time, right? This one's at time 0, this is at time 1. So what do I need to do to the 2,000 to make it be at time 0? What do you do with this to make it from time 1 back to time 0? Guess where we use the interest, yep. So what do we need to do to it? I think it's time 1, so I don't need to do v squared. I just need to do v, right? Just need to multiply by a v. And then the next 4,000, is that money coming out or going in? Try that again. Going out or coming in? It's coming in, isn't it? For the 4,000, and what we need to multiply it by? V squared. So this is what we mean by net present value. And we can figure out the net present value. This is also where this is what I meant with you can use that cash flow worksheet now too. If you actually wanted to figure out what the net present value is, because you have the interest rate. And then that's what that NPV button is for on your calculator. But we don't need it in this case because what are we doing? This net present value is also supposed to be the same as the net present value for project Q, right? So what does the net present value look for like for project Q? Positive 2,000 minus, I think it's plus 4,000, right? Because that's coming back. V, and then what are we going to subtract off? X v squared, yeah. And you know what v is, right? So you can figure out x pretty quickly. Cool. That's what I said about 0.90909. Is that what you wanted to see, Sid? Yeah. That's what it is. We'll talk more about net present value later in the semester, too. It's a way to evaluate, and if you take corporate finance, you'll also do it in there. Are you taking it now, or are you taking it later? That's it. Basically, what they use it for is to evaluate if a project is going to turn out to be profitable for them. So if it has a positive net present value, then it's worth the investment. If it has a negative net present value, then it's not. A lot of those things are estimates, but that's the idea. Let's see. For 7, I don't know off the top of my head. What'd you get?
Not one of those.
Not one of those?
I got D.
Then I'd say you did something wrong. Do you want to do one with an annuity?
We still have the annuity on number
So number
3.
three?
The cost of forced interest on number 3, actually. I guess that was the integral one.
Okay, so at the end of year 2, George puts in 400 into it. That's another reason. That's another thing they have to be careful of reading these problems. At the end of year 2, George puts 400 into an account paying interest at that force of interest. Year 2 is from time 1 to time 2. That is the second year. It starts at time 1 and goes to time 2. So for this particular force of interest, what does your lower limit of integration need to be?
It would be 2 to T, right?
It'd be 2, yep. So you need to do, for that accumulated value for George, you would have 400, and it would be e to the integral from 2 to n.
Just figure out what it's wrong.
Okay.
See that, and 1 over 6 plus T.
Yep, that's
Yeah,
right.
Split up my 1 over 6 plus T.
Oh, that'll do it.
And read it wrong. And
That'll do it.
my integral ended up being funky.
That would be funky. I agree. So that gets at that force of interest part.
I
So
got D.
got D on 7 as well? Okay. Haley, did you ever get D?
Nope.
It's
So-
10 over 11, not 1 over 11. That's your D. Probably getting 1 over 11.
There you go. All right, so you
We do 11.
want to do 11?
Yeah.
All right, so, pardon me. Jerry makes deposits at the end of each quarter for 10 years. At the end of 15 years, Jerry will use the fund to make annual payments of Y at the beginning of each year for 4 years, after which the fund is exhausted. Determine Y. I personally think this one might be a little bit easier to see what's going on with the time value diagram. Oops. All right, so it says that Jerry's going to make deposits of $450 at the end of each quarter for 10 years. So we've got 450, 450, 450, all the way up to 40 quarters, right? 10 years. And then, past that time, I'm going to switch my scales. Nothing happens at time 11, time 12, time 13, time 14, time 15 in terms of years. But it says after 15 years, at the end of 15 years, they'll use the fund to make annual payments, Y, at the beginning of each year. So once we get to time 15, we're going to start making payments at the beginning of each year. That's where your Y comes in. And then that's what exhausts the fund. So we need to find a meeting place for these to set them equal to each other, right? Right? We got to find some place to set these things equal because he's going to use, this is basically like a retirement account, right? He's putting in money up until here, and then eventually he's going to use it for income later, right? So he's going to use the amount that he put in for each of the quarters, for 40 quarters, to buy something so that he can get that amount later on. So you've got to pick a time at which to equate these things. For me, there are three obvious places where you would equate them. One's at time 0, because that's probably the most obvious to equate all the time, right? Try to make their present values equal. I guess there's actually 4 obvious times you might try to equate them. 0 is 1, right? Especially since I can calculate this present value easy, right? 10's another one, because I can calculate the future value of this easily. Or else would be another one that's kind of obvious. 15, right? Because I can calculate the present value, or at least the present accumulating factor of this one easily. And then the last one would be 18, and just move everything to the end. Then you got to be a little careful with that one.
So say, since it's in like months, it's quarterly, would you just do the 450 times 4 and then the rest, so you can set it up in years?
What do you mean?
Since it's an annual.
Yeah, you have to be careful with your interest rate. That's exactly right. Yeah. So this is one. That's disgusting. Looks like there's blood in there. This one's giving you an annual effective rate, but your first annuity that you're given is given quarterly, right? So to be able to do this first one, do you have a preference on what time you want to move things to? You like 0? Okay, we'll do 0. I want to take these payments and move them back to time 0. Is that annuity immediate or annuity due? Immediate, right? So this will be A angle 40 with some interest rate times 450, right? Do you agree? A angle N is, well, sometimes. A angle N is our present value. But I don't know what this J is, because I got to change the J from an annual effective to a quarterly, right? So this J, we're going to calculate this fashion. That's how we have to figure out. Because when I compound that quarterly rate 4 times, I have to get the annual effective rate. So you've got to calculate your J separately. Yes.
What's happening between 10 and 15?
Nothing. Absolutely nothing. Didn't put anything in. Didn't put anything in. Didn't take anything out.
So the money they keep on putting in.
So this will keep growing. Yeah, it'll keep growing. Now, if you're going to use your calculator on this one, which I would highly recommend that you use your calculator on this one, make sure that when you find your J, you multiply by 100 before you put it in your I/Y. Because your I/Y is a percentage, not a decimal. Right? It's another easy mistake to make. Alright, so this will give you your value at time 0. Now I need to move this to time 0. How do we move that to time 0? If you're going to equate them at time 0, how am I going to move that to time 0? Okay. Well, except those are actually yearly payments in this case, right? And we have the yearly rate, don't we? I can use the 0.07 for that one. Well, that depends on how you're thinking about it, okay? I know that the problem tells us that we're making it at the beginning of each year, but you can do it with this A, provided you adjust the other part appropriately. If you just use an A without an umlaut, where does it take you to? It's present value for things that are at the end of the period. So this will be not at time 15, but time 14, right? It'll take you here. So to get it all the way back to 0 now, what do I need to multiply this by? I gotta get from here to here now. What do I need to multiply by? That's your question. I got a lump of money sitting at time 14, I need to move it back to time 0. Well, give me a letter that I can use. About V. To what power?
14.
14th, good. What's that V going to equal? Oops. 1 over 1.07, right? Because it's just, that's time 14 in years, and we have a yearly effective rate, right?
We should get the 1.7.
It's a yearly effective rate of 0.07%, right?
1 plus 0.
This is using that conversion we talked about way back up here.
No, I mean, I get the, sorry, that was very confusing. I'm looking at the 1 plus j over 4 to the 4th equals 1.07.
Yeah.
I'm guessing you got it the same, or the same way of getting it, but like, oh, you're just converting.
I'm just converting it. We're given an annual effective rate, and I've got a quarterly annuity. So I've got to change the annual effective rate to a quarterly rate. I can't just divide it by 4 because it's not a nominal rate, it's an effective rate.
So you can't just say that you're paying 450 times 4 a year and then use the rate.
You do it that way because those other 450s sitting in there and accumulate interest. And if you do it the other way, they don't accumulate interest. So it'll change your. It won't, for the numbers this small, it won't change it by much, but it'll change it. If you have really big numbers, it'll change it. So you can't do it that way. Unfortunately. It'd be nice if you could. No, that's why you have to change your interest rate. All right? Let me know what time you're coming in tomorrow or Wednesday. Either or is fine. Again, we don't have class Wednesday because you're taking the test.
So then we just set the 2 annuities.
You just set them equal to each other when you're trying to solve the y because you now know this value. Okay. All right? Sorry we were a little late. Have a good one.